Welcome. So today I might look at this problem. So there is a tricky thing about having um, stuff like um, top level, basically top level conditionals. Uh, in this particular case, I got an error report. We're saying that this didn't work, and it correctly didn't work. So, like, if I do like this, it will produce an error, even though. Oh, sorry, I had jumped to that particular error. Okay, let's continue here. So, yeah, you got like, oh, it's an error. The object class could not be found. Did you spell it right? Actually, you get it twice. That's interesting. Why I get it twice, but the problem is how do you even get it? So maybe I should just fix that first. It's always good. So I got this error here. That's not supposed to be so. Okay, so I got this. So let's just attack that first. So you get it twice. So you get it here, and then you get an reporter on Dekel, right? So and then what happens after that? Let's see what happens. So it will jump back, and then it will actually probably give you that information. So it's okay. So it's a null, and then what happens is you go back and then try to register that one. Let's see here. So it's not a generic. So let's go in and do that, and then you get like it can't be fine. So what the problem is here is that if you ever get this an error on Dekel, you need to poison it. Dekel poison and this declaration. Let's see here. So or not that one. So okay, let's see. So you get a resolve. And you don't get a found. So what happens? You get an error in there, and then what you want to do here is that on this one, so you want to register this one, resolve the type info, resolve the symbol. What happens? So it's not a generic one. So let's see why that continued there. So okay, we're here, we resolve the symbol. Try to resolve it is a generic. And this one should be silent actually. So can we get this one? So Sima resolve symbol silent something. So this one will resolve symbol common, which is, so it's a find symbol, I think. Yes, find symbol. So we want to find find symbol and this unresolved name. Oh wait. So we might have okay, find path symbol. So Sima find path symbol. Now we get the path. We also get to span. Oh yeah, because it's an error. It has to handle the error, but we don't need to do that now. So it's like this. and I just get one error now. Okay, but the problem is this. We can just stop it here. So almost impossible to fix. And if it's impossible to fix, like what you do then is not say like, oh, yeah, it's hard to fix, and then you kind of give up. You have to think about where the semantics, like how do the semantics have to change in order to make this work. So what you essentially get, I can make a smaller reproduction of this that is even smaller. So you're gonna create a module, call it foo, and it only happens if something is true. And here we have a struct which is called foo and just has a member. Now, what did I do wrong here? Oh, got this. Okay, so and then we get another module which is called bar, and it's going to import foo, right? And then it's going to extend foo to have a method called baz, and it takes itself and doesn't do anything. Now, if I compile this, it will break in the same way. Right, so boom, it's not there, you can find it. But if I remove this, it will find it. Oh, by the way, everyone hearing things, well, it's like I didn't turn off the mic or something. No, it looks good. Okay, so the problem is that when we want to resolve something, so we want to look at this module, for example, we have already registered that there is some kind of method here, there is a function and stuff. Now it has to resolve foo. Okay, so it will look at foo, but the problem is that because foo has a conditional, so it's just there if it's true, right? So what we want to do is not get stuck in bad things. So the bad thing would be like this, okay? Like I have something like this, and I say, I create the env module. So we have like std core env. Okay, and in that one we say like we add a constant foo, and it's true. Now this one will be automatically injected into everything. There are other ways to do that, but if it's true, then we want to include this. Right? We want to do it conditional. Just include this if foo is true. And now, sorry, I have to make this a little bit easier. So now it doesn't work. But if I would do like this, what would happen then, you think? Well, now it works. In fact, I could just call this true, and it would work. Yes. So the problem here is if I want to evaluate things in here, I need to first know that should appear. And I know that should appear if it's included. But to look at that one, I need to register this first. So in order to do that, what you do is that first look at all the modules that don't have anything attached to it. So all non-conditionals. And then we can resolve all of those and try to register everything in them. And then we go to the next step. Now the problem is that sometimes a module might be like the generic module might be dependent on things. So the way we have these passes that occur, so let me just show that. So we start by setting up the module hierarchy. This is just which one is the parent module, which one is the bottom module. And we just do this because of how the module system works in C3. The relationship is important, so we do that setup. It's very fast. Then we want to process the imports. So the imports are run. They are never conditional, so you know for each module section what it imports. And then we're going to register the global declarations, right? So here is where we have problems, right? Because now we're registering the global declarations, and then we go and register the methods. But in order to register the methods, we need to know the global these conditional declarations in the conditional units. So kind of what could be done is putting them here. I don't know if there's a downside to that. We're probably going to see that. So right now, okay, so this one actually works automatically regardless of everything. So foo could not be found. Did you spell it right? So even though we did reorder this, it was not, let's see here, why it didn't work. So let's see. Okay, so methods and then post register and then analysis. So that's a bit odd. So it should have processed these like so. But in general, this is like a very annoying problem. Here you just register stuff, right? So you just register global declarations, and you have the methods, and yeah, the problem is that there's a type def. The problem is the type def. It's you could do a lot of things if you didn't have to resolve the type defs. As here in the conditional units, it's going to includes. So it's going to do all the includes in there. And then the conditional declarations in all of these units. So this is going to be interesting. So let's see here. We go in here. Because if things are right, we should be, processing our we're going to make this easier too. So we're going to run this without a standard library. Because if we run this without a standard library, we don't have to worry about any other code being tested on our own. So we get this very, very quickly. So foo path is not found. So let's see here where things go wrong. So we kind of get to this point, right? So here we have to get to this point. So we are here. Right, and then we run the pass on which module? So we run the pass on the core module. Okay, so it's done. And then we run this on bar as well. And let's see, did we get any errors? No errors yet. And then we're gonna register. Oh, did we get any errors? No. So let's see, did I square? No, okay. So now we're going to go to the next stage, and the next stage is going to be for what module and what stage. So the stage is analyzes global registered global declarations. And let's go, we're going to go into this. So we're going to register the global declarations for the modules, and that's going to be fine. No? What the heck? Right, okay, so we're here. So we register for core. We registered that one. Still no bugs. And no, we register for foo. And I suppose this one is breaking it. No. So now we're registering bar. Right? And we don't have anything. Oh, let's see here. So bar. Oh, bars are, yeah. That's the one we are, which has the normal things. Okay. So what the declarations, the current declaration is the BAS. So let's register that one. And let's see, it's a function. No. Yes, it is a function. Okay, so it is going to get, it's a type parent. Do we know anything about it? It's just going to add that one to the registers to check. And then we get out of there. And then we finished that pass. So we're going to go to the next pass, I think. No. Oh. Oh. What am I doing? What am I doing? So, okay. Like this. This is what order is saying, is not the order of the switch cases. Okay. We didn't have a main forward function, yes. So, like that. And now it works. What happens if we run the test library, the tester, everything on this? I don't think it'll work, but who knows? Maybe it's as simple as that. That would be weird. But maybe it does work when I think about it. Okay, let's see if I have any questions so far. No questions. 4 viewers, no questions. Everything is like crystal clear. No questions. So this is weird. It actually does work. So what I did was basically do the includes are running here. Whoa, that's not good. So let's see. So the includes are running there. So we need to run the includes before. So something like that. Okay. Let's see if this passes. Actually, this is the correct one. And if this actually works, and maybe it doesn't work for someone. Meanwhile, I'll just grab this thing, which is a test case now. Let's call it a module method module something. So, okay, we have modules like import. Okay, we have something about or methods. So new file, method extension in conditional module, very short name. let's add that and put in there. So maybe this works actually. Maybe this solves everything. Because the modules, what it doesn't solve is using modules like there is a problem when you want to conditionally resolve something that depends on the module. So we have this thing here, so we can play around with this. So let's say I want to say that the I have another function here, bar, and that one should only exist if foo methods is larger than 0. And then we're going to call bar, right? So it's going to look like, does it have methods, and how long is that, and if it's more than that number of methods, then it's included. Now let's see if this messes up things or not. Well, it should work, right? Because we already defined that one. There's this really weird situation when you run that one in the parent one, but let's see. So let's run just we assign the library now for everything. So let's go ahead, and what does it say? Oh, sorry, it's not, it was methods of, right? Methods of. I forget these names too, which may, so bar could not be found. Maybe we can make, let's see what the value is, right? So we can set a constant, or it's going to, let's return this, right? In here, we can return the number of methods. So it's going to be, it's the returning 1. As you see here, it's returning 1. So the problem is that, like, when we are resolving this, we have not yet resolved the methods of foo. And this kind of dependency is just like a mess, right? It's something you want, but it's also something that is a mess. So this kind of thing is super fragile. And really the only way this works is when we have a generic module. Then this makes sense. But here it's, I mean, once we get here, we have ordered, like everything is registered, everything is fine. But here, trying to figure out if that one has a method, you can easily get like, okay, so what would happen if you have something like, what do we just add this if that one is 0 or something, and you see the circular kind of resolution that has to happen. But the problem is that while it searches for resolution of types, the problem is when you kind of get into if statements, because you don't know like if it's going to be in there or not. Does it exist? Does it, like, how does it behave? So one way to do this would certainly be to store everything. So you have like, there are multiple bar, and it's not until so you can make another bar here, right? So you can say like, okay, if not methods of len, then we have this bar, right? And that should obviously work, right? It should be fine to have this. Okay, so methods of again. So in this case, we would get this bar. Let's like, we can just do this so we see which one. Print in bar 2, and you know, bar 1. Okay, and then we call a bar from here because we will have a bar. So don't drink too much in the bar. All right. So here. Oh, missing the end. Blah 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 blah. Okay, right. So return 0. Okay, so you get bar 2. What happens if I remove this? Like this would be interesting. Like I think it still doesn't work, right? Because now we kind of moved method resolution a bit later, right? And then we could just add, foobar, a foobar here, just to mess things up a bit. So in this case, does it work? Which one do I get? So foobar, math, and blah, blah, blah. Okay, you have to have self. So let's have the self. All right, maybe self. Pass by value. Oh. Let me get a foo for you. Let's make a temporary foo and call bar on that one. And we get bar 2. So in this case, he didn't see the Baz, and I don't know if that's like ordering or when this is resolved actually. I think maybe now we were solving this before everything. So what we did was that we import everything and resolve everything, and so now we can't use methods of really to exclude something. So let me look at the standard library and see how that worked and if we rely on that anywhere. So I think we might do that. So let's see here. So methods of, absolutely no use of methods of. Let me think about that. So, oh, it's defined as well. So we have like define, probably a define. So finding files, let's have a define. So for example, is ALS defined here? So we have something like that, right? And this one is fine because it's inside of this thing, but we get like into problems here. So if we say, let's say it's, I don't know, if I make a module that's parameterized, so module, I wouldn't use bar, so a module called Baz, and it has, it has a type. And let's say if it has a type, then we're going to if the type, so we're going to have a function called test if the type has more than like non-zero functions, right? So now it's dependent on what the type is. So let's say we want to call that. So we're going to call, we're going to import that one as well. So we want to import Baz as well. Sorry, I'm just putting this in the same file. It looks like it looks horrible. So it's called Baz. So we're going to have like Baz and then test, and then we use foo, right? So foo like we don't know how many functions it has, but it's going to call that, and then we call it that with some. No, it doesn't have an argument. So like this, right? So here it kind of should work. Because the generic resolution happens afterwards. So let's see if this works. So, and it actually, let me show you that it's actually printing that. So we have to import, bottom import std here, and then test. And we can test, and then we have the type as well. So we can take the type Nemo, right? So let's do that, and we can see that it works. So we see that it has the foo. So in this case now, it will work. Um, there's also the question. I think this kind of works. I think at least it works better than the current situation. But it's a general problem. It's a I think that like maybe the best thing would be to store all the types and all the names and like keep track that they are registered but they have like multiple definitions. So then you can see kind of it's there, and then you have to check later for things. I don't know if to solve things like, okay, let's say we did that. So in this case, let's say we then store um, we just store two of these bar and we don't know if they're there or not, right? So we haven't resolved that. So there are two unresolved things, and then we're going to start. Okay, let's resolve. Then we have a list of methods, right? So we have a list of methods for foo that we haven't resolved, and we're going to start resolving them. But then we can look. Okay, we are resolving the methods of foo, and that's going to be circular. That might work. Maybe just group them on foo. If you have the type def, then they always know which one to group on. So maybe it's the type def that has to change as well. So what I'm going to do is like, even though I know this is kind of bad, we need to kind of this is better than it was. Unfortunately, it's better. And the this ordering thing, you have to be like super careful when you play around with that. And it's easy to get really trapped in what is resolved or at what point. That's just the way it is. So let's this change like fix is a fix or a change, like a fix. Change ordering to simplify adding methods to types in conditional modules. And let's see what the diff was for that. I don't know if you can see this window, so I'm actually looking at this is the window for committing these things. So I'm going to grab these the changes. So and double check what I did. The ordering there, I changed the ordering a bit. Let's see here. It's going to fix the code a bit so it looks better. And then we have the test case. And so we're almost done. We're just going to run the tests again. So last stream, I did some work on the costs as well. So the cost used to be opaque, kind of opaque anyway. It was like a cost thing, and then inside of that would do different things depending on lowering. And the downside of that was that there was no real analysis of you couldn't kind of jump past the costs without doing like a lot of like thinking, reasoning about it. Like let's say you turned an int into a bool. That was a cost, and just like if you just look at the expression, it's just okay, it's a cost. But now it's that's hard to kind of switch on, and it's easy to like forget some cases. So what we did, sorry, it's a bit later. So what we did last time was to kind of move some of those into normal calls, normal expression nodes. And actually, last night, or actually in the middle of the night, I did fix all of the remaining cases. So now there is no cost expression once you lower things. And I also changed some things where there was some code. So we got less code in the compiler. I think there is now, because of that, there is room for simplification that I haven't looked at right now. So every time you do a refactoring, that there will be like parts of the code that's no longer necessary, or has, there are duplicates or something. So you really need to go through that and do the cleaning. But I don't know if I should do that now or look at something else. We're also thinking about like what should we do. There's another bug, by the way. There's a bug with lazy expressions not being. Oh, we're done. So let me just check this in. So just going to push this, and I'm going to hope that I'm not destroying anything for anyone else. It's a trade-off. Hopefully, sorry if I'm breaking anything. Okay, so it is not final. 0.66 is not 0.66. Yes, it's not final yet. So this is kind of the latest I can do. I'll be a little bad about that. Okay, so the problem we have is this. So now let's erase this part and look at something else. So we're gonna make a macro, and the macro is going to do bad things. So it's gonna take a lazy argument, and it's gonna be an int argument, and then let's just add those together, right, and return that. So okay. We're gonna import std, and I just do this import std. Don't do that unless you're just playing around with things. This imports the whole standard library, but you can do that. You don't have to worry about things like namespace begin polluted or something. It's mostly going to work fine. Okay, but what happens here? So I want to call this with I could call this with, let's say, if I just call this with foo with io print n hello, right? So this ought to work. Oops. Cannot do the addition of void to void. Oh yeah, println doesn't have that. So println doesn't return a value, but this one does, right? So we can actually look at this as well. So this actually will return a u like this, and then we can print that. Let's assume it's safe, right? So let's do like this. No, that's fine. Okay. But let's say we want to, so it is delayed and just acts differently. So just it's called. So let's put this here, right? So we have that one, and inside of this, rather than to have just that one, let's take an expression block, and then we're going to have like, let's print the value here, right? And then we don't even need to do that. Well, let's just make it even easier. So we're going to have like this, right? So we're going to print what that one is, and then we're going to go out, right? So let's do that. Oops, sorry. Which one? Names or types? I forgot an ending like that. Okay. Oh, printf addition any to int. Oh yeah. Okay. So let's think like this. I am unsure what happened there. Can it do the addition any plus int? But it is typed. Weird. Let's see. Maybe something happening. That one is fine. So wait, did I already handle this? No, that works. So okay, and then we're gonna print out what I is, right? So what is the I when you print it twice? It's like just going to go there, right? And if you notice, like it's supposed to be int, but it's not. So let's also grab the type, right? And we're gonna make a variable here. Okay. So what happens now? We get 1, 2, and 3 because this type of also evaluated this thing, and that runs at compile time. Okay, and looks like I am out of use on my laptop. I'm gonna go grab something to load up. Right. Okay, so let me see if there are any questions. No questions. 8 viewers, no questions. You're so silent. I don't know that you're there. Like, write something in the chat. Or maybe I worried that you died or something. All right, so this is a problem. You don't want this to happen because if I am to check that this is an int, I want to do the type of, right? I want to do type of to see that this is correct. So maybe I just going to, gonna have a require that the type of lazy is going to be int. Right, let's require that. Now, this is going to be it's going to be unhappy with me, of course, right, like this, because it's not. It's violated. But let's say something like this then. Maybe it doesn't work because it's right. Well, let's get the inner, right, type of. Okay, let's remove the. So okay, so now what happened? Now we are running this and it's increasing it by 1, and then we're running this and it's increasing it by 1, and then we're running this by 1 and this by 1, and the final thing is 4. So this is sad, and while there might not be any way to kind of like handle this with this type of, what you can do, there are different things. Like one, the obvious thing is like saying this. Okay, you can't do anything about these variables. They are not there. It's an error, right? The second thing you can do is like saying, okay, let's try to restore. Once you get out of this, you try to restore this to that value, but that still leaves this thing being weird, right, inside of it. And there's another one which says, okay, maybe you can't mutate these. Like if it's from from another, from another scope. Like here, we are talking with, like doing stuff, and would be manipulating this from another scope, and that's not okay, right? That's no, and you would get an error on this one, right? And so that's an option. And but one of the ones that I kind of like, it's it would say like, hey, when you do like this, it's evaluated once, but it's always evaluated. So even if you had something like this, right? So you just had like this, even if you had just this, it would still evaluate things just once, right? Let's remove this require. So here it would just do it once, and then what would happen is that you do get, then it would kind of use the result, and just it would basically give you, it would lower this one to the value which would be 0, and you would get like 0, 0, 0 every time. So that's a way to get this, because right now we can't. If we want to evaluate that, we're essentially doing a type of, and if we're doing a type of, we're going to mutate this. So this is fine, completely fine, if we have something like this, because now we're not doing anything at runtime, compile time. But so as soon as you have this you're doing something at compile time, and things get really weird, and you don't want that. So this kind of a question. On the other hand, the argument for not allowing this is that this is sick and weird. Did you have? This is kind of it's like borderline weird. So maybe you don't need this thing mutating inside. And you can also say like, okay, let's say that, but I mean the argument for just doing this once is kind of good, because you're basically passing this to something into one of these macros, and you shouldn't think about, like, from a reader's perspective, it doesn't know what foo does. But if I don't need to understand what foo does, I can say, okay, it's just going to increase this by 1, and that's all that's going to happen. It's always going to happen. Then it's compile time. I know that's going to happen. That's like very predictable and nice. So we might try to do that. Okay, it's 10:50. Actually, this is like a working day. Maybe I shouldn't, do this now. But we can look at where the code is. So we're gonna go into when you analyze a parameter. Maybe I should mention another thing. We can do that later. But essentially, what you do here is you have a delay thing that actually has had this fix, which is annoying too. So what it does, kind of stores the context and the span, and when you want to resolve a hash, this calls hash variable here, what you do is you do a copy of this the int expression here, and then you kind of resolve that at that point. And this is kind of what you want to do. But there's and this, so then you could do this once, and then you could just do the copy. So you could copy that already resolved thing. We're gonna look at another thing, another kind of these. While these are annoying, it's like they feel so good actually. You know, deciding these kind of corners of the language and really dealing with them, because if you don't, like, once you dealt with them, the semantics is very clear. I mean, it doesn't matter what semantics are, you just have to be really clear semantics. You have to know what the program does, and if you don't know that it's kind of does different things, then you're like C++ land or something, where things do very different things depending on small changes in the code, and it's like it's very horrible. It's horrible. So that's why you like C, because C always gives you like, this is the thing that happens, even it's a bad thing. Like when you have macros in C and you just copy them, but you know that it always copies them. It just doesn't like, oh, sometimes it copies and sometimes it doesn't, depending on like what mood or what, like if there are vars or something would do something different. That's something you don't like. Actually, there are some things like that in C, like when you are using some of these like type-offs and stuff, where you can force things to kind of resolve sizes. Especially if you have type-off, you get like some kind of compile time evaluation that is very stunted and weird. So you can get weird things, but you like in vanilla C you don't get them, because vanilla C didn't have type-off. But now it has, so we're gonna have like more corner cases, and we already have the corner cases in C with the arrays that have variable runtime sizes. So it's going away, thankfully. But I mean, it's super convenient, but it's also crazy. The whole thing is crazy the way that it's implemented. So because you can just blow things sky high by doing something accidental. So okay, so we kind of have maybe a way to address this. There's another thing. Another thing actually in macros. So there is something called a ref argument. So you can write them as like this. Okay, so this is kind of overloaded because you kind of use it for other things. But the thing it's supposed to be like C's ref arguments, but it actually gives you a pointer. So something I can just do like this, right? So we're going to go for that. And now we're going to have a variable. We can have a float even higher, so it doesn't matter. So we have a float AA. So it's a very good game. And then we just going to go foo and then AA, and then we're going to print what that is. And we're going to see that this actually does work. Otherwise, everything is weird. So it's going to be like, yeah. So what you're saving here is essentially, you don't need to do, if you could have this and you could have, this is all you're saving, right? You're just saving doing this, right? So it's not a huge deal, but it can kind of look better. There's one more thing, and I think this works. I just have to check that. So let's say we have float b, which is a pointer to a. So bb is a pointer to a. And now let's remove that, and then just run this. I'm kind of curious as to what happens now. So This probably doesn't work. No, it doesn't work. You have to do like this and it will work. So this obviously works. But there is a question if I do like this. No, that was the wrong thing. I don't remember if it's like, it has to be a float point, right? So no, it doesn't do that. So the useful thing would have to be like, you could, if you could have like, you could do this and you can also do, you know, that would be useful. Right? You could do it with either. But this isn't very useful. So the only reason why this is like okay is because if you have something like this, right? And let's say that's, you know, you're gonna get, you want to do like this, right? So it's and then you're gonna pass it the a. You might think that this works, and it shouldn't work. There are. Oh, it does work! When did I? Okay, so so there are limits to what hash is supposed to be able to do, and this one just like blows through this. This is a giant regression. But this means it actually already does everything that, you know, you can write swap now. So you can do. So the bad thing is, like, you know, we talked about that, but the bad, like, you could write swap too, like A and B, and then we get like var temp is A, and then A is B, B and B is A. Right, let's do a swap. We have a float AA and we have a, let's see, okay, B is 42. So let's swap them to AA, B. Does this work? Oh my god, it does. Oh, this is not supposed to work. I don't know where that restriction went, but this is very bad. But anyway, this kind of reveals how this lazy. I mean, I was thinking that I would implement this, but it already works like that. So the downside here is we can't. How do we test the type? So we go and say something like require, not like that. Require. You know, we can say. I don't remember. I have to jump to this like the same type. Is same type, right? Require. Is that a built-in or is it? No, it has to be values. Okay, so values is same type A, B, right? Now we require it to be the same type. This is not. You can be a bit more generous with this, but now it kind of requires they are the same type, so we get better error messages. So let's see that this worked. Yes, that worked. And then if we make this one int instead, it will complain, right? So here we're gonna get like, okay, require is violated. What? And then we can like say, okay, what happened if we remove this, right? So what happens if we remove this? And then we get this. We should get an error like float cannot be implicitly converted to int, but you may use the cost, right? So this is the way we kind of, we can say like when arguments commands must be the same type for swap 2, right? And then we run this, and then we get okay, so arguments must be the same for swap 2. And actually, yeah, I was thinking of having a way to kind of do this nicer. So I was thinking about this, like having, you can have like parameter A, right? And then you say, then it would be like, or B, and then the error would be like on, like instead of having it on the this call, it would be on this parameter. So B would get like the error message. But that's not now. It's not in there. So let's see if there are any questions. So okay, sorry here. So okay, I see Converti is saying hello, and then let's see. I still have to wrap my hand around compile time versus runtime macros. Aren't they always compiled? Yeah. So B equals temp. No, what? B equals. Oh yeah. Yeah, I didn't check that one. Sorry, that was bad. But let's see. So we can just print both of them. So and we have to change that now. Right. Good catch. Good catch. So now we should see them. Yeah, changing places there. Yeah. So it's. I mean, this is still runtime, right? So this is not really compile time. But once you do things, you know, you can do what's compile time is something like, yeah, we do, you know, for I equals 0, I minus 10, I plus plus, and then we do something like habit. And for, I mean, it looks ugly, and that's intentional, so that you can just see this as something else. So I'm sorry about that, but that's the way it is. So we can do like this, right? And now we get this kind of generated at compile time. So the trick is to kind of think of this as going away, or comment it out or something. So you're going to get this the code that's not prefixed with $. That's when you get. So there's going to be something in here too, you know, something in here that's going to be replaced. But there is nothing else funny going on, and you always know what the you know, if you have one of these, they are always compile time. So yeah, it should be fairly. So if you do something like this, of course, it looks like this, right? So now you get to 1, 2, 3, and we can put this in here as well. Maybe you can put like, okay, we can paste this times a, right? So this is completely okay. So what we get, like 0, 1, 2, 3 in this, right? So I can there was a bunch of them, so you get to those. So again, you can think of it as basically comment dot these rows, so you get this printed. But the tricky things, like when you start doing conditional things and kind of, you know, if blah blah blah, then keep this. And I mean, if this is like better than it used to be, because if you had like top level if blah blah blah, and then you have something like this, then you don't even know what's inside, and it could be anything, and it's just much harder to actually reason about. Yeah. Anything else? Any other questions before I close for today? Right. So, any other questions? Everything is crystal clear. Anything you want me to show or look at before I finish this? So, yeah, back to the thing about semantics. I think it's super super important that you actually work out semantics that is well defined, and you kind of see it's so tempting to kind of you remember the case when you have this, you had this kind of something happens that is you know like this, right? So here we have, right, this is just well evaluated that, oh, couldn't be found. Oh, it's not because it's not here. X 0. So if you have something like this, yeah, you can't assign to a constant. Now that one folds the X. That is interesting, actually. That's good, but it's interesting. So and we had this, the problem we had was like this, right? So we can have something like that, and then we gonna print it. So this is our problem, and it's tempting to kind of just ignore it and hope it goes away and have, okay, sometimes it, undefined. What happens if you put in this one in a lazy? Oh, it's undefined. But undefined semantics is just a crap excuse for not making a decision. It's tempting. It's very, very tempting, but it's also very crappy. So better have some semantics that are somewhat annoying but predictable than having no saying it's just undefined. Don't do that if you're making a new language or you're working on updating a language. Yeah, I think I'm happy there. Yeah, so thank you for watching, and have a good evening.